Hi everyone, and welcome to the class of geometry. The topic that we are going to talk about today is the introduction to geometry. We are going to know about what the geometry is and the basic elements that you need to know for apply later the axioms and theorems involved in the geometry topic. First of all, we are going to define what is a geometry. Geometry is the study of geometric figures in two dimensions. Plane geometry is called, and three dimensions, in that case, is solid geometry. In our case, we are going to start to work within specific three things for the geometry application. The first thing that we are going to take in account in this course is going to be the perimeter. And what is a perimeter? Perimeter is the distance around the outside plane of a plane figure. For example, in a polygon, the perimeter is the sum of the lengths of the sides. As you can see, the perimeter are formed, in this case, is the length of the four lines that form the geometric shape. The next important thing that we're going to work with in this section is going to be the areas. And what is an area? The area is a measure of how much space there is on a flat surface. As you can see, the area is the inside part that exists inside of the perimeter. As you can see, it's all the part that is in yellow color. And finally, the other thing that we're going to work with is going to be the volume. And what is the volume? The volume is the total amount of space enclosed in a solid. In a particular example of perimeter, area, and solid, you can see better the difference between each. For example, this one. If you have this geometric shape and you talk about the perimeter, what is the name of? The name of it's going to be the circumference. The circumference, it's talking about the other round of a circle. But if you are referring not only to the circle, you are referring the inside, including, in that case, it's not going to be a circumference. It is going to be a circle. And if that circle becomes in 3D object like that one, in that case it's going to be called a sphere. So here you can see what is the difference between perimeter, area, and volume with exactly the same geometric shape. The geometric shape is the circumference that is the base for make the circle and sphere. First of all, we're going to talk about the angles. And what is an angle? When you have two straight lines and that straight line start in a coincident point like that one, this part is going to be called angle. The angles are represented usually with Greek letters like alpha, beta, gamma, or theta. Now we are going to see the types of angles. The type of angles of the classification of the angles, it depends of the opening that they have. First of all, we're going to talk about the acute angle. Acute angle. For example, this is going to be an acute angle. And what is the characteristic of this acute angle? The characteristic, the principle is that the angle theta, is going to be more than 0 and less than 90 degrees. So this angle is going to be between 0 and 90 degrees. Next angle is going to be called right angle. And the right angle is when the opening is exactly to 90 degrees. And in that case, the representation of the opening is not going to be a curve, it's going to be a square like here. Next one is going to be the obtuse angle. What is an obtuse angle? An obtuse angle is going to be something like that. As you can see, now the angle is going to be more than 90 degrees and less than 180 degrees. The other one is going to be the straight angle. And the straight angle, it's going to be an angle that is exactly 180 degrees. Okay, like here is going to be exactly 90 degrees. The double right angle is going to be a straight angle. And finally, we're going to see another angle that is going to be called refract angle. Let's write over here. We're going to have the reflex angle, and the reflex angle is going to be an angle that is going to be more than 180 degrees. Okay, so here we have the different types of angles: acute angle, right angle, obtuse angle, straight angle, and reflex angle. Okay, remember that an angle is the opening between two straight lines, and that straight line starts in a common point, and the measurement of that opening is going to be on degrees, and the representation of that angles in mathematics is usually represented by Greek letters. Continue with the angles. We need to talk about more characteristic with them. First of all, we are going to talk about what is a complementary angle. When you have two angles and then you add that angles and the result is going to be 90 degrees, those angles are going to be called complementary angles. For example, let's suppose that we have here 90 degrees angle, but this is formed by two angles. For example, the first one is going to be this one, and the other is going to be this one. This one is going to be of 30 degrees, and that one is going to be of 60 degrees. So it means that 60 degrees and 30 degrees are complementary angles, because its addition is going to be 90 degrees. Okay, as you can see over here. Other one is going to be the supplementary angles. Let's write here supplementary angles. Okay, look at this. This is going to be something similar with the complementary angles, but here instead to have 90 degrees, we need to have 180 degrees. For example, maybe here I can have this angle that is going to be of 120 degrees, and here I'm going to have another angle that is going to be 60 degrees. So means that 60 degrees and 100, I'm sorry for this one, and 120 degrees, those are going to be supplementary angles, because both are going to form a straight angle. Another characteristic that we need to talk about is that what happens when we have angles in parallel lines. Look at this. If you have one line and then you have another parallel line and then you have another extra line that is not parallel to that one, what is going to happen? Well, in that case, it's going to happen a lot of important things that you need to see. For example, this angle and this angle, if you can see, if you add both angles, I mean, I'm going to call this angle A and this angle B, those angles are going to be what? Supplementary angles. Because if you add A and B, you are going to have a straight angle. I mean 180. Okay? And then, if you can see, this angle is going to be repeat. Where? Over here. So this is a reflection of that one. Okay? And B is going to be this one. Okay? So the angles are going to be repeated, but on inverse way. So it means that AB, BA, AB, or BA, they are going to be exactly the same. A plus B, they are going to be supplementary angles, but they are going to reproduce exactly in the same way over here. This angle is going to be exactly this angle that I'm going to call A, and this one is going to be exactly this one, A. Now this is going to be B, and this is going to be B again. As you can see, we have a lot of repetition of the angles. In fact, we have two angles, but each angle is going to be repeated 4 times. And sometimes when you have a problem with that, and you have, for example, only this measure, to complete the all the information is going to be very easy, because you know that here you have only supplementary angles. So the thing that you need to do, you have this information, it's just to make the difference with 180, and then you can got this angle B, and then you can reproduce in the other angles that you have over here. And it happens when you have an angles in parallel lines. Right now we're going to talk about the geometry shapes. And what is a geometry shape? Well, this is going to be a geometric figure, an object that we're going to work in a flat surface. Okay, and the geometric shapes are going to be classified by the side that they have. First of all, we are going to talk about the geometric shape with 3 sides. Okay, 3 sides. And the 3 side geometric shapes are going to be called, and I'm sure that everybody knows about that, triangles. Okay, but the triangles are, the triangle is a very important topic that we need to talk about seriously, because it has a lot of characteristics and theorems that we are going to talk about later. But right now we are going to talk about only with the classification, because we can classify the triangles according, first of all, we can classify the triangles according with its angles. Okay, according with these angles, we are going to have 3 different types of triangles. The first one is going to be some triangle, for example, like that one. As you can see, all the angles that we have inside of the triangle are less than 90 degrees. Remember that the angle that is less than 90 degrees, between 0 and 90 degrees, is going to be called acute angle. So in that case, this is going to be called acute triangle. Why acute triangle? Because all the angles are less than 90 degrees. The next one is going to be this kind of triangle. And here we have one particular thing. What happened with that angle? That angle is right angle. So that's why this is going to be called right triangle. And finally, we're going to have a triangle like that one, but as you can see, we have here a particular angle that, as you can see, is more than 90 degrees and less than 180. And the angles that are between 90 degrees and 180 are going to call obtuse. So in that case, this triangle is going to be called obtuse triangle. Okay, and this is the classification according with its angles. Now the other classification is going to be according with its sides. Okay, now let's see the examples. First of all, we're going to have this triangle. The measure of this side, the measure of this side, and the measure of this side is going to be exactly the same. The name of that triangle is equilateral triangle. Equilateral means that they have the same measure of the three sides. The next triangle is going to be something like that. Look at this. The measure of this one is going to be this one, represented by this line, but this measure and this measure both are the same, but this thing is different to this one. What is the name of that triangle? In that case, that triangle name is isosceles triangle. Okay, and then the last one is going to be something like that. Here, this is going to be the representation of that measure, this is the representation of the other one, and this is going to be the representation of the other one. As you can see, we have three different sides length. So in that case, it means that we have three different measures. In that case, that triangle is going to be called scalene triangle. Okay, so remember, triangle is the geometric shape with three sides. You can classify the triangle according with its angles: acute triangle, right triangle, and obtuse triangle. Or you can classify according with its sides: equilateral triangle, isosceles triangle, and scalene triangle. Okay, even you can mix it. For example, this one, this right triangle, maybe if this measure and this measure will be the same, it means that it's going to be a right triangle, but even it's going to be an isosceles triangle. Okay, or for example, this one, this is equilateral. As you can see, if this is equilateral, so the internal angles are going to be less than 90 degrees, so it means the equilateral triangle is going to be an acute triangle too. So you can mix it. Okay, and another important thing that you should know always is the addition, and we're going to write over here. This is another characteristic very important, is the addition of all internal angles of a triangle always will be 180 degrees. So it means that here in equilateral triangle always is going to be 60 degrees each one, because you need to divide 100 degrees on 3. Okay, so this is something very important that you should know. Now, how can I calculate the perimeter of the triangle? It's very easy. Just the only thing that you need to know is the side's length, and then the only thing that you should do is to add the lengths. And how can you calculate the area? In that case, you can calculate the area multiplying the base of the triangle times the height and divide over 2. Those are the formulas that you can work for calculate the perimeter and area of the triangle. The geometric shape with 4 sides are called quadrilateral. Why it's quadrilateral? Because it means that it has 4 sides. And here we have a different classification. So first of all, I'm going to talk about the first classification, that is going to be called the parallelograms. What is a parallelogram? The parallelograms is when you have quadrilaterals with the pairs of sides in parallel way. For example, here we can talk about the square. This is going to be the first one. Let's write over here the square. Why the square? Because as you can see here, the square is when we have a quadrilateral with the same length sides, but this line is parallel to this and this one is parallel to this too. Here we have 4 right angles. Okay, so this is going to be the first parallelogram. The second one is going to be the rectangle. And the rectangle is going to be something similar to the square, but here we're going to have 2 pairs of different measures. I mean, this measure is going to be exactly like this, and this measure is going to be exactly like this. 2 pairs of measures, and this line and this is going to be parallel, and this are going to be parallel too. As you can see, the angles, the internal angles again are going to be right angles. And finally, we're going to have a rhombus. The rhombus is going to be another quadrilateral, but here we are not going to have, look at this, we are not going to have internal right angles. The angles are going to be different, as you can see, but this line is going to be the same length like this one, okay, and this line is going to be the same length like this one, but this line and this line is going to be are going to be parallels like that one. Okay, and finally we're going to have the rhomboid. Okay, and the rhomboid is going to be something similar to the rhombus. Okay, as you can see, this and this measure are going to be the same, and this and this measure are going to be the same. The internal angles again are not going to be 90 degrees like that one. Okay, so this is the first 4 parallelograms that we have: the square, rectangle, rhombus, and rhomboid. Now the other classification on letter B is going to be the trapezoid, or yeah, the trapezoid or trapezium. Trapezoid or trapezium. Okay. Okay, what are the different kind of trapezoid or trapezium? In that case, well, one geometric shape like that one, for example this one, is going to be called a trapezoid or trapezium. Just okay. And as you can see, we have here a 90 degrees, another 90 degrees, and then one obtuse angle and one acute angle. Okay, this is going to be a trapezoid or trapezium. But exists one that is going to be something like that, that is very similar to an isosceles triangle. It looks like a isosceles triangle cut. Look at this. In that case, the measure of this and this are going to be the same. This one is different to this one, but this angle and this angle is the same, are the same. This angle and this angle are the same. So in that case, it has a name. It is going to be an isosceles trapezium. Okay. Even if you have another trapezium like that one, it's going to be a trapezium too. Okay, this is not isosceles because this angle is not the same like that. And like that one, the measure here is different to this, different to this, and different to this. Okay, so here this measure is different to that one, different to that one, and different to that one. And isosceles trapezium, it's this one is different to this, but those are the same. Okay, same sides, different sides. This is isosceles. It's isosceles because of these measures and because of the angles. Okay, but here we have a trapezoid, and isosceles trapezoid. Okay, and finally we are going to talk about the last one. The last one is going to be called, letter C, kite. Okay, the kite is going to be something similar to rhombus, but it's not going to be the same. The kite is going to be something like that. Okay, two same angles, two sides with the same length, and two sides with the same length. But as you can see, the difference with the rhombus is that this and this well are the same, but here this and this are the same and they are in front of, like that one, and in that case not, in next to. So that's why it's going to be called kite. Okay, well, another thing that is very important that you need to know is the addition of internal angles of quadrilaterals is always, as you can see here, we have the answer: 90, 90, 90, 90. It's always 360 degrees. Remember that with the triangles is 180. In that case, it's going to be 360 degrees. And finally, what are the formulas to calculate perimeters and areas? In that case, the perimeters for the parallelograms is very easy. Just add side 1, side 2, side 3, and side 4. Okay, just add the side. In that case, it could be more it's going to be more easy, easier if you only multiply 4 times the length. Alright, but in general it's this one. And the area is going to be base times height, and that's all. One side is going to be the base, and the other side is going to be the height. Here in the trapezoid and trapezium is going to be different. Trapezoid or trapezium, well, the perimeter is going to be the same. Just add side 1, side 2, side 3, and side 4. But the area is going to be the next way. First, you need to add the major base plus the minor base, and then you are going to multiply times the height and divide over 2. But look at this. For example, in this one, what is the major base? The major base is this one. The minor base is this one. And the height is going to be that one, not this one. The base always should be measured with 90 degrees with the base. Okay, so in that case, this is going to be the height. Here, let's write here height, major base, minor base. In the case of the isosceles, here the major base is going to be this one, the minor base is going to be this one, but the height should be this one. Remember, it's 90 degrees with the base. This is going to be the height. In this one, it's going to be exactly the same. Major base, minor base, and this is going to be the height. So this is the formula for the trapezoid or trapezium. And finally, let's continue with the kite. The kite is going to be easy. So here, as you can see, we're going to, like in the other ones, forget the perimeter. So the only thing that we need to do is to add each side. Okay, and the area is going to be measured with the next formula. First of all, look at this. Here you need to measure the distance between this and this point. In that case, we are going to talk, or we're going to classify this distance like a D1, and the other is the distance between this point and this point. We're going to classify like D2. With those measures, you are going to apply the next formula. The formula is you need to multiply D1 times D2 and divide over 2. And this is all about the quadrilaterals, parallelograms, trapezoid, trapezium, and kite. From here, we're going to have only a geometric shape with 5 or more sides, and they are going to be called polygonal. In that case, regular polygonal, because exists just not regular polygonal. Okay, the first one that I'm sure that you know about is going to be the pentagon. Then this is with 5 sides. Then we are going to have the hexagon with 6 sides. Then heptagon with 7 sides. Then octagon with 8 sides. Then nonagon with 9 sides. Decagon with 10 sides. Okay, let's go with an example of some regular polygonal. In that case, we have an octagon. As you can see, we have 8 same sides, so that's why it's going to be called regular polygonal. And in that case, I need that you understand some elements that we have over here. Okay, first of all, here just in the middle we are going to have a point. That point is going to be called center. I'm going to write here center. Remember, center is the point that is just in the center. Okay, other thing that you can see is if you, let's try it with other color to make the difference. If you make a line from one vertex is this point. Okay, the vertex is the point when you have a like a corner. Well, this is called vertex. In that case, that one is going to be radius. I understand that this is not a circumference, but if you make a circumference from here to here, the circumference is going to pass for each point of, for each vertex of the octagon, so that's why it's called radius. Okay, other one that is very important to know is this one. Is the line, the straight line that go from the middle of the, the center of the polygonal to the middle side of one side, the middle point of one side, like that one. And another important thing is that is at 90 degrees from one side, whatever side. Okay, in that case, this is going to be called apothem. Okay, those are the three things that you need to understand, that all the regular polygonals, pentagon, hexagon, heptagon, octagon, nonagon, decagon, they have exactly, and obviously with 10, 20, 30, whatever, they have exactly the same elements: center, radius, from the center to each vertex, and half of them from the center to the middle point of each side, and is to 90 degrees with what? With the side. Okay, and why is important to know that? Because, well, first of all, if you want to know the perimeter, well, in that case it's very easy. The only thing that you need to do is just multiply the n. N is the number of sides that you have times the L. L is the longitude of each side. Okay, but if you want to calculate the area, in that case you are going to use one thing over from here. Well, in that case I'm going to call the apothem with letter A, capital letter. Okay, because it's perimeter is the perimeter times the apothem over 2. So it's very important to know what is the apothem. You need to calculate the apothem to calculate the area. Okay, and this is all about the geometric shapes in 2D. Now let's continue with 3D geometric shapes. Remember that we are not going to only to calculate the perimeters and areas. We are going to calculate also the volumes. Okay, so first of all, we are going to talk about the cylinder. What is a cylinder? Cylinder is a geometric shape where its base and its top is circular, something like that. Okay, and the important elements that you need to know for calculate the volume of the cylinder are going to be the height from one way and the radius of the circumference that you have in the base or in the top. So the final formula for calculate the volume is the multiplication with pi times the square radius times the height. Next one is the cone. the cone is something similar to the cylinder, but it is going to have only one circular part. Here we have the base and the top, and here is only the base. Okay, and remember that elements that you need to know for calculate the volume are going to be two. First one is going to be the radius or the circumference again, and the other one is going to be the height, but the height is going to be calculated from the base to the top. Okay, so this is going to be the height. It's very important not consider this side like a height. Remember that the height should be always to 90 degrees with the base. So the final formula for this the cone is going to be 1/3 of, or multiplying by pi, times square radius times height. Something very similar to the cone. Next one is going to be the square pyramid. Square pyramid. Here we're going to have a pyramid with a base in square form, something like that. As you can see, here we have the inside sides. There we go. This is the pyramid row representation, and here we need to know the longitude of the base. All the longitude, I mean this side or this side length is going to be the same because it's a square, like here. So the base is a square. And the other thing that we're going to know, that we need to know, is the height again. And again, I need to tell you that the height should be considered from the center of the base to the top. I mean, it should be 90 degrees with the base. It's the measure of 90 degrees with the base. This length side is not the base. Okay? And the volume is going to be calculated by 1/3 of cubic base times the height. And finally we're going to see the prisms. Okay, exist different kinds of prisms. For example, I can take for example a square, and then I'm going to have a square prism. Or maybe instead of square, it could be a rectangle prism, something like that. Or we can have maybe a triangle prism. So the triangle prism is going to be something like that, something like this one. Or even, well, as you can see, this is something similar to the cylinder. Cylinder could be considered a circular prism. Okay, why? Because the top, as I told you, the top and the base are going to be the same geometric shape, 2D geometric shape, like here. The top and the base are going to be squares. The top, let me draw it over here. There you go. The top and the base are rectangles. Here, the top and the base are triangles. Here, the top and the base are squares. Even we can have another kind of prisms using whatever regular polygonal, like for example, let's try to do an hexagon. Okay, the hexagon is going to be something like that. Okay, we're going to add some height, something like that. and then we are going to have an hexagonal prism. And as you can see, the top and the base are going to be hexagons. Okay, so the prism will be named according with the shape of the top and the base. Okay, good. So in this case, it's very easy to calculate the volume. What you should know? Okay, you should know the area of the base or of the top. It's the same. Okay, you need to have the base area. In that case, you know how to calculate the square, rectangle, triangle, or hexagon area. Okay, and just multiply times the height, and that's all. You will have the prism total volume. And here we have the most common 3D geometric shape that we're going to use: cylinder, cone, square, pyramid, prisms. And we are going to see later a lot of problems when we are going to apply this kind of geometric shapes, and that can be occur in their daily life. Finally, I would like to finish with a very important geometric shape and very useful in the real life. I'm talking about the circle or circumference. Okay, we talk about that. Okay, first of all, let's talk in 2D. Let's talk about the circumference. Okay, remember that I told you that the circumference is going to be just the outside circle. Okay, the outside circle is going to be the circumference. Okay, what are the elements that I need to know for calculate the perimeter? In that case, the perimeter of the circumference. It's just one. You only need to have the radius. Remember that the radius is the distance that you have from the middle point to whatever point of the circumference. Okay, and the perimeter is going to be calculated by the multiplication of pi times the diameter. And hey, we don't have here a radius. Well, the diameter is 2 times the radius. It means the diameter is the distance between this point to this point. I mean, from side to side, passing for the center. Okay, so other form to calculate the perimeter over here, it's going to be 2 times pi times the radius. And this is 2 forms to calculate the circumference, okay, of a circle. Then we're going to talk about the circle. In that case, the circle is not just the outside. Well, I'm sorry. Well, let's suppose that this is a circle. It's not only the outside part of the circle, is all the inside part. Okay. In that case, what does it mean? It means that we're not going to calculate perimeter. We're going to calculate area. Okay. Let me finish to start to draw it. Okay, there we go. And the area of the circle is going to be calculated by, well, what is the first element that I need to know? Again, is going to be the radius. Okay, so the area is going to be is pi times the square radius. Okay, this is going to be the circle formula to calculate the area. And finally, if we transform this circle in a 3D geometric shape, we're going to have the sphere. Okay, in that case, well, if I just draw this one, well, it's not going to look like a sphere, but maybe if I made something like that, maybe it's going to be like a sphere. Okay, But again, the distance that we have from the center of this sphere to one side, that is going to be the same to whatever point or side of the sphere, it's going to be the radius again, and the volume in that case is going to be calculated by the formula of the multiplication of 4/3 times pi times the cubic of the radius. And we conclude with this very important geometric shape. The geometry is a mathematical tool that is not going to help us only in the school. It is going to help us in the daily life, because we have a lot of real life problems that happens every day on our lives. So thank you for watching this video. It was the introduction to geometry.